Most maps portray the solar system as silent, static orbs floating in a void. In reality, this is a 4.6 billion-year-old dynamic system driven by a massive, burning engine. That hostile environment is currently occupied. It is humming with a live network of human-made machines. Right now, real-time data is flowing from the deepest reaches of space back to our planet, a continuous stream of telemetry pulsing across the void. Humanity has established an active robotic empire. It stretches from the sun's scorching outer atmosphere to the freezing edge of interstellar space. To see the true scale of our cosmic neighborhood, we have to look past the static diagrams and ride along with the active fleet currently patrolling its frontiers. We start at the absolute center. The sun holds 99.86% of the system's total mass, and the Parker Solar Probe is currently diving through its corona to measure the energy of the solar wind. This diagram of the early solar nebula shows a critical thermal boundary known as the soot line. Near the young sun, heat reached the boiling point of hydrocarbon molecules, ensuring only dense metals and silicates could survive in solid form. Because these materials only comprised a small fraction of the nebula, the planets that formed here were limited in size. These became the 4 rocky terrestrial planets, including Earth. Today, this rocky zone is heavily monitored. We maintain a constant presence around the Moon, with orbiters like LRO and the Chang'e rovers active on the surface. On Mars, a scientific armada is at work. The Curiosity and Perseverance rovers are sampling the soil, while the Trace Gas Orbiter monitors the atmosphere from above. The inner system is no longer an uncharted frontier. It is a heavily monitored research zone defined by its proximity to the Sun. Moving outward, we reach the asteroid belt, a torus-shaped ring of primordial debris that failed to coalesce into a planet. Active probes like OSIRIS-APEX and Lucy are currently analyzing these objects to identify the chemical signatures present at the birth of the system. Beyond the asteroids, at roughly 5 astronomical units from the Sun, we cross the frost line. This is the temperature boundary where volatile compounds like water and methane finally freeze into solid ice. The abundance of ice past this line allowed these planets to grow massive enough to capture vast atmospheres of hydrogen and helium, creating gas giants like Jupiter and Saturn. Our current foothold in this region is the Juno probe, which is engineered to survive the intense radiation and magnetic field surrounding Jupiter. Operating beyond the frost line requires machines that can function in different extremes, navigating dark, freezing environments and intense planetary radiation. The geographic scale now shifts drastically outward. Moving past Neptune, we enter the trans-Neptunian region. This is the Kuiper Belt, a vast, icy debris field populated by thousands of small worlds and dwarf planets like Pluto, Haumea, and Eris. The New Horizons probe is currently flying through this deep, dark zone, continuing its mission to study the outer reaches of the belt. This macro-scale view shows the absolute edge of the Sun's influence, the heliosphere. At a boundary known as the termination shock, roughly 120 AU away, the solar wind crashes into the interstellar medium. Voyager 1 and 2 have successfully pierced this boundary and entered interstellar space. Although they rely on 1970s technology and decaying power sources, both Voyagers are still actively transmitting data back to Earth across billions of kilometers. These probes serve as our outermost outposts, proving our technological reach extends to the very edge of the Sun's physical influence. As we reverse course back to Earth, we pass through a stratified system of fire, ice, and radiation. It is easy to think of humanity as being confined to a single pale blue dot, but through this active fleet, our human senses have left the planet. We are seeing Martian sunsets, listening to the plasma of Jupiter, and touching interstellar space. By maintaining this permanent network across billions of kilometers, humanity has already become a sprawling, interplanetary species.